Today's topic is derivative. Okay, in the earlier video I talked about the limits. Now we will learn about the derivatives. Okay, so what is mean by the derivative? Let's suppose f is a function, real valued function. Okay, function. Okay, and a is point in its domain. Domain means where function is valid, function is exist, is its domain. So derivative of f at a will be limit s tends to 0 f a plus h minus f a upon h. Okay, this will be the derivative of function at point a. Okay, when a it's in domain means it is continuous in this at point a. Okay, then it is also denoted by f dash a. Derivative of f with respect to a is denoted by f dash a. We will do some problem based on it. Find out the derivative at point x equals to 2 when function is given as fx equals to 3x. Okay, fx equals to 3x. So applying this limit s tends to 0 f a plus h. A is here 2. So 2 plus h minus f 2 upon h. Okay, on substituting, what will we get? F, replace x y 2 plus h, here replace x y 2. So we will get 3 2 plus h minus 3 2 upon h and limit s tends to 0. Three into 2 6 plus 3h minus 6 upon h. 6 plus and 6 minus cancel out, 3h upon h, that will be 3. So derivative of the function fx at this point x equals to 2 is 3. Now we will learn when we use derivative in real life. Okay, sometimes any vehicle or any rocket or some machinery is running some speed. Okay, so we wants to get the velocity at a specific point. So we use derivative, okay, for the instantaneous velocity, This is also derivative is also rate of change of one function with respect to another function. Okay, sometimes we see that water is flowing in any tank, or so we want to get the time when it will be filled. So in that case we use derivative. Also like some rocket is going is moving around the earth, so how much time will it take to pass the gravitational force? So what velocity is required? So in that case, derivatives help us. Now we understand the geometric interpretation of it. Function as the graph such that it is the fx function. This is x coordinate, this is y coordinate. So here a point A, so value will be fa. Here point A plus h, value will be fa plus h. So this is point P, this is point Q, here we say, okay. When we find out the slope of PQ, what will be the slope of PQ? Slope of PQ equals to f y coordinate, that is y2 minus y1 upon x2 minus x1. Okay, y2 f a plus h minus fa upon a plus h minus a. So that will be f a plus h minus fa upon h. So slope of PQ is this. Okay, if this point, both points meet each other, so this line will become this chord will become the tangent. This will become the tangent. If s tends to 0, both points will coincide. So slope of PQ, now it will be the slope of this tangent. Okay, slope of the tangent equals to limit when two points coincide, s tends to 0, f a plus h minus f a upon h. Or this is also, we have earlier studied that is the derivative. So that is the derivative of function at point A. So this in another mean, this is the geometrical representation, this is the slope of the tangent at that point. And we can say slope tan, if it make angle psi n1, so tan psi equals to f dash a. If f is a real valued function and limit exists such that limit s tends to 0, fx plus h minus fx upon h if limit exists, then derivative of f dash x equals to this. This is called the first principle of derivative. Okay, this can also be denoted by df upon dx. Okay, also sometimes if fx equals to y, so dy upon dx, also d upon dx fx at given point. Here are some properties of the derivatives. If function is written in the as a summation of two functions, so d upon dx fx plus gx, that will be, first we take the derivative of this plus derivative of this, d fx upon dx plus d gx upon dx. Okay, if function is written as a multiplication of two functions, then we take the differentiation of this, so dfx upon dx, leaving another function as it is, plus take the derivative of, keep the first function as it is and derivative of another function. Okay, we can, if fx and gx are u and v, so one more thing, dy upon dx can be written as y dash. Okay, also if y equals to fx, then f dash. So u and v are two functions, then differentiation of those, derivative of this, u dash v plus u v dash. Similarly, division, we can derive this. Okay, how do this formula we get? So differentiation of this, multiplication by this, minus first as it is, denominator differentiation upon square of denominator. Okay. We will do the some problem based on it. If fx equals to sin x, okay, what is the derivative of it? Fx equals to sin x, so differentiation is f dash x equals to limit s tends to 0 f x plus h minus f x upon h. So substitute x by x plus h. So limit s tends to 0 sin x plus h minus sin x upon h. Okay, we know that sin a minus sin b, that is 2 cos a minus b y2 and sine 2 cos a plus b by 2 plus sine a minus b by 2. Okay. This is the trigonometrical function, that sine a minus sine b equals to 2 cos a plus b by 2 sine a minus b by 2. So apply it here from the formula of sine a minus sine b, that will be limit s tends to 0. Here x plus h is a and x is b. So 2 cos a plus b, x plus h plus h, 2x plus h y2 sine a minus b, sine x cancel out h y2 upon h. Okay, rearrange it. Limit s tends to 0 cos x plus h by 2 sine h by 2 upon, here 2 can be taken below. Look here, we know that limit s tends to 0 sine x upon x, that is equals to 1. So here sine h by 2 upon h by 2 will be 1 and s tends to 0, when apply here that will be 0, then will be cos x. So derivative of sine x equals to cos x. I hope you are understanding the problems that I am solving here. If you have any doubt, you can comment. Okay. Or if you find any difficulty in any problem related to this topic, you can ask this and I will make the video on that problem also. Find the differentiation of sine square x. Okay, so I told you that differentiation of u v equals to u dash v plus u v dash. Okay, sine square x can be written as sine x into sine x. Okay, so d of sine x into sine x, look here, we will first we differentiate it, d upon dx sine x, keeping second as it is, plus keeping first as it is, differentiation. In previous video we learned that d upon dx sin x, differentiation of derivative of sin x is cos x. Cos x sin x plus sin x, here cos x. Sin x cos x cos x sin x. This is sin 2x, or this is 2 sin x cos x, or which is equals to sin 2x. Okay, I use this if function is given as a multiplication of two function, so we will differentiate, we will find out the derivative of first function keeping the same second as it is plus keeping first as it is and differentiation of second. Okay. We can do it in different manner. Sin square x, we know that sin square x, 2 sin square x equals to 1 minus cos 2x. Okay, so sin square x equals to 1 by 2 minus cos 2x by 2. Now we will differentiate. Differentiation of constant function is 0. 1 by 2, 0. Second method. You should not be confused. You solve avoid this matter, but sometimes you can take the help of this also. Differentiation of 1 by 2. Differentiation of d upon dx sin square x equals to d upon dx 1 by 2 minus cos 2x upon 2. Okay. d upon dx 1 by 2 minus 1 by 2 cos 2x. Differentiation of 1 by 2, constant function is 0 minus 1 by 2 constant can be taken out, d upon dx cos 2x. Okay. So d upon dx cos 2x. We know that differentiation of cos x is minus sin x. Okay, but here is 2, so differentiation of cos 2x will be minus sin 2x, and here it is not x, it is 2x. So whatever is there, we will differentiate this function. Differentiate of 2x. Differentiation of 2x will be 2. Okay, so that will be minus 2 sin 2x. How will I get it? First differentiate assuming that it is x. What? When we assuming this is x, then cos x will be minus sin x. So 2x will be 2x. Then what we assumed here? So 2x, then we differentiate this also with respect to x. That will be 2. So minus 2x, minus 2 sin 2x. Replace it here. Minus half differentiation of cos 2x into minus 2 sin 2x. So 2 will cancel out, that will be the sin 2x. So I have solved this with 2 methods. I hope you understand it. Find the derivative of x plus cos x upon tan x. Okay. So this is written in the form of u upon b. We know that differentiation of derivative of u upon b will be u dash v minus u b dash upon v square. Okay, here u is x plus cos x, numerator term, denominator is 10x. So x plus cos x upon 10x differentiation. So first differentiate this x plus 10x multiply by x plus cos x. Cos x multiply with 10x minus x plus cos x as it is multiply by differentiation of 10x or derivative of 10x divide by 10 square x. Okay. So how will you differentiate? Differentiate x, find out the derivative of x, that will be 1 cos, derivative of cos x is minus sin x, 1 minus sin x. 10x is as it is minus x plus cos x, same. Differentiation of 10x is sec square x upon 10 square x. Okay, that is our answer. So I have covered different types of the problem in this video. Still you have the problem, you can, okay, I forgot to mention that it is chapter taken from the 11th class book, limits and derivative, and I cover limit in earlier video, and now I cover derivatives in this video. Okay, if you understand the concept, if you like the video, please subscribe my channel. Thank you.